When we separate a mixture through paper chromatography, we're going to be breaking down the mixture into the different particles, the different components that make up that particular mixture. So one way that we can examine quantitatively what our mixture is made of is by calculating the retention factor, the RF. And we're going to start out by using our filter papers that we obtained through our paper chromatography experiment. So this is one of the filter papers. And you can see that there's a variety of colors on here. So we need to first look at the different colors that we see. So if you look closely, you see lots of different colors that are presented here. So we have purple, we have sort of this fuchsia color, pink, it goes to white here, and then red. So when we conduct our measurements, we're going to use this line here as our starting line. That's going to be our 0 millimeter mark. And then we're going to measure to about here for the purple, the fuchsia, pink at this line, and then the red actually traveled all the way up with the solvent. So it traveled the distance of the filter paper. So our equation for calculating the retention factor is going to be the retention factor equals the distance that the pigment traveled divided by the distance that the water traveled. And I've used these abbreviations here to represent the actual equation, which is the distance that the solute travels divided by the distance that the solvent travels. And we're using water as our solvent, and our solute, our thing that gets dissolved, is going to be our different colors in our pigment. So it's going to be the pigment that's in the markers that we're using. So I've lined up the ruler here at the starting line. So this is our 0 millimeter mark. And I've drawn this bracket to represent about where this purple color stops. So our purple, the darker purple color, is going to spread from our starting line to here, which is about 2 centimeters. So that's going to be our DP. That's going to be our value that we have as the numerator. And our distance that the water traveled, our distance that the solvent traveled, is going to be the entire length of this filter paper from the starting line, our initial starting at 0 millimeters, to 15 centimeters. So when we plug this into our equation, this is going to be 2 centimeters divided by 15 centimeters. If we look at our next color, which is this fuchsia kind of color, it goes from 0 millimeters at our starting line to about 6 centimeters. So that's going to be the number we have on top as our DP. And 0 millimeters to 15, the extent of the water traveling, our solvents travel, is going to be 15 centimeters. So that's going to be 6 centimeters divided by 15 centimeters. If we look at our pink color, it stops here at about 8 centimeters. So that will be 8 centimeters, the DP, divided by 15 centimeters, which is the DW in our equation. And our last one is going to be red. So it goes from 0 all the way up here to 15. So this will be 15 centimeters divided by 15 centimeters. So that one is going to equal 1. And so that means basically that our red pigment traveled the entire distance of the filter paper. It traveled as far as our solvent did. And so that will end up being just 1 because it will equal out. So that explains how to calculate the retention factor when we're doing paper chromatography.